Hello everyone, welcome back. Let us see the part 3 of the video, geometry with complex numbers. And in this video, let us start with the concept that is a very famous concept and very important, extremely important concept, that is rotation principle. So let's start. Let us suppose that there are three complex numbers, z, z1 and z2. And suppose that they are non-zero complex numbers in complex plane. Okay. Now let us suppose that there are 3 points in complex plane and whose fx's are the complex numbers z, z1 and z2. So let's first draw the real axis and imaginary axis. So this is complex plane, this is real axis and this is imaginary axis. Let's say there are 3 points, okay, in complex plane. Let's draw them. So let's say there are 3 points. This is first point, this is second point, and this is suppose third point. So let's say these are 3 points. This point is P with fx z, this point with A with fx z1, this point P with fx z2. And suppose that this angle is theta in anti-clockwise direction. Okay. Now what rotation principle states, what rotation principle basically is, how do we apply the concept here? For that, let us redraw this P A vector and P vector, and let us extend them in backward direction so that it cuts somewhere the real axis, right? So let's say, let us draw these things. This is PA vector, and this now I'm drawing is PB vector, and I have extended them in backward direction so that they are cutting. Let's say this is the real axis, the green line. So let's say that this real axis, so and these two vectors are cutting the real axis at 2 points, as you can see the diagram. So now let me draw the detailed diagram here. Okay. Let's say this angle is theta, as I have shown there also. And so as you can see here, that if I assume theta is equal to theta, and the two angles as theta 1 and theta 2, so theta is equal to theta 1 minus theta 2, and from there theta 1 is argument of vector z minus z1, theta 2 is argument of vector z minus z2, and from there we are getting applying the concept of property of arguments. So we are getting this theta is equal to argument of z minus z1 by z minus z2. Now any complex number in Euler form can be written as z equal to mod z into e to the power iota times argument of z. Therefore, if I replace if I consider the complex number z minus z1 by z minus z2, so can be written as z minus z1 by z minus z2 equal to mod of z minus z1 of z minus z2 into e to the power iota, and then argument of z minus z1 to z by z2 is theta. So this is whatever I have written there. Now if I apply the property of modulus, so I get z minus z1 by z minus z2 equal to mod of z minus z1 by mod of z minus z2 into e to the power iota theta. And from here, mod of z minus z1 is distance between A and P, so which is equal to AP, and mod of z minus z2 is distance between B and P, so this is equal to BP. So finally, you are getting this formula according to the rotation principle. So how to apply it? So when you are drawing the angle, mark it with 2 dot. As you can see, yeah, I've marked with yellow dot. So the angle starts with the BP and ends at AP. So that's why AP vector is z minus z1 divided by BP vector is z minus z2. That is equal to AP by BP into e to the power iota, and since theta is positive theta, so I have just written plus theta. If I take the angle in opposite direction, that is in clockwise direction, then angle terminates at BP vector. So BP vector is z minus z2. So z minus z2 divided by angle starts at AP vector. So divided by z minus z1. That is equal to BP by AP into e to the power iota and minus theta. Why? Because angle is in clockwise direction, and these two are actually same. If you just take the reciprocal of every term in the first equation, you are getting the second equation. That's it. If you take the reciprocal of every term in the first equation, you are getting the second equation, and both are same. So the concept is that you have to first mark the angle either in anti-clockwise or in clockwise, and you have to start with the vector where the angle is terminating. Okay, so let us see, after you have understood this concept, and since this is very important concept, let us see another concept, that is unit vector in complex plane. You already know unit vector in Cartesian plane. Unit vector R is written as any unit vector definition of, according to definition of unit vector, so it is having unit magnitudes, and mathematically unit vector R cap is written as R divided by mod R. Similarly, e to the power iota theta, so mod of e to the power iota theta, you know it is equal to 1, so this is equal to unit vector in complex plane, and that is, this unit vector is inclined at angle theta with the positive direction of real axis, right? Now how can we say that this is a unit vector? Because if I take z is any, suppose that z is any complex number, okay, whose magnitude is R, and argument is theta. So z in Euler form can be written as r into e to the power iota theta. Now e to the power iota theta can be written as 1 into e to the power iota theta. So from here also you can conclude that this is a unit vector because its modulus is 1, or you can say magnitude is 1. Otherwise you can directly find its modulus, writing this in polar form and then applying the formula of modulus. Again you are getting 1. So e to the power iota theta, that is equal to cos theta plus iota sin theta, and is modulus is equal to 1. Argument you can see from here is theta. So this is basically p, let's say whose fx is e to the power iota theta, and this vector is inclined at angle theta and its modulus is equal to 1. Therefore we can consider OP vector as a unit vector in complex plane whose fx is e to the power iota theta, or simply you can write that OP cap, as we know that unit vector are represented by cap, by adding a cap above it. So you can write that unit vector OP is equal to e to the power iota theta. Simply unit vector OP is equal to e to the power iota theta. Further you can also write that e to the power iota theta is equal to cos theta plus iota sin theta, but that is understood to you already. Fine. So if we have to think a unit vector in complex plane that is inclined at an angle theta with positive real axis, then we can directly assume e to the power iota theta as a unit vector. Now let's say that modulus of z is equal to r and argument of z is equal to theta. So in Euler form we can write this complex number as z is equal to r into e to the power iota theta, right? So this is, let's suppose that this point P whose fx is z. So OP is equal to r and this angle is equal to theta, and therefore the OP vector is equal to z, that is equal to r into e to the power iota theta. Therefore OP cap, that is equal to OP vector divided by mod of OP vector, that is equal to r e to the power theta divided by r, that is equal to e to the power iota theta. So now it should be very clear. It is very analogous to the vector that you study in Cartesian plane. Very analogous. So this is OP vector in complex plane. That is inclined at angle. I mean OP cap, that is OP vector, unit vector in the direction of OP vector. E to the power iota theta. Now let's say z is a complex number in Cartesian form. Let's say this is x plus iota y, and in Euler form let's say z is z. So if I multiply the complex number z with e to the power iota theta, then the new complex number, that is z into e to the power iota theta, is a rotated vector of the vector z. If we rotate vector z by an angle theta in anti-clockwise direction in complex plane, we get a new vector, we get a new complex number, that is z into e to the power iota theta. So how can we imagine z and z into e to the power iota theta? Suppose that this is point P whose fx is z. Then if I rotate this vector OP by an angle theta in anti-clockwise direction, the new vector, that is OQ vector, you can treat it as, is actually z into e to the power iota theta. Fx of the point Q is z into e to the power iota theta, because we have multiplied z with e to the power iota theta, so the vector gets rotated. Now modulus of OP is equal to modulus of OQ, that is equal to mod z, and mod z, as you can see here, it can be, if it is 1 then both are unit vector, if it is not 1 then length of both vectors will be same. And you also know by now, it must be clear to you that one vector can be obtained from other vector just by multiplying by e to the power iota theta. In case if you want to obtain OP vector from OQ vector, you can multiply OQ vector by e to the power minus iota theta. So as you can see from here, if you multiply further z into e to the power iota theta into e to the power minus iota theta, you are again getting z. So which means that if we rotate OQ vector in clockwise direction, minus theta means clockwise direction, by an angle theta, we are again back to the position OP vector, right? Clear everyone? So the conclusion is that if we multiply any vector in complex plane by an angle by e to the power iota theta, then vector gets rotated. The magnitude remains same, but vector gets rotated by an angle theta. If theta is positive, then it gets rotated in anti-clockwise direction. If theta is negative, then it gets rotated in clockwise direction. Further, it is not necessary that it should be the position vector, that is, it should be its tail should be at origin. No, it is not required that the tail of the vector should be at origin. It can be anywhere. Just if you multiply the vector, suppose z minus z1 is a vector that is somewhere in the plane, you just multiply with e to the power iota theta, vector gets rotated. This is the simple thing. Based on this, let us see a question that was asked in IIT JEE 2009. At that time, JEE once was called IIT JEE. So question is saying that a man walks a distance of 3 units from origin in complex plane towards north 45 degrees, that is northeast, okay, direction. Further, from that point, from there he walks a distance of I think 4 units, 4 units in the direction of, or you can say towards north 45-degree west, that is northwest. Okay, now northwest direction in complex plane and then man reaches a point B. Fine, the question must be clear to you. Man starts from origin, walks it 3 units along northeast, and then after that walks 4 units along northwest. Finally it reaches the point B. Now you have to, out of 4 options, you have to find which option is the correct answer for the position of point P, that is affix of point P in complex plane. In case of Cartesian it should be position vector. In case of complex number it should be affix of point P or simply position of point P. There are 4 options. As you can see, options are in this format, in the format of e to the power iota theta. So I think that vector approach of solving this question is the best approach. Let us see how. Or if you want to solve this question on yourself, okay, this, as I said, this question was asked in 2009, IIT 2009. At that time the advance was called IIT. Now this question, if you apply the rotation principle and if you apply the vector concept in complex plane, then this question can be solved within a minute. Within a minute, I'm telling you, or maybe in lesser than that. By drawing the diagram, and if you know the correct procedure, you can solve this question within a minute. But only if you know the rotation concept and the vector concept and you apply them correctly. So let's see the solution. Let's say that this is real axis and let's say this is imaginary axis. Okay, now since the man is starting from origin and walks as it is saying that 3 unit towards north 45-degree east, so at a direction inclined to 45 degree with real axis, assuming real axis is representing the north direction and imaginary axis is representing the real axis is representing the east direction and imaginary axis representing the north direction, as we know already. Let's say that this length is 3 unit and then after that it is going towards northwest and then after moving 4 unit it reaches to point P. Suppose that affix of point P is Z, as I have assumed here. So what is actually, you have to find this position vector of point P. This vector you have to find. In fact, you have to find OP vector in terms of complex number, or you can say you have to find OP vector in complex plane, right? Now as you can see that magnitude of OA is as given is 3 unit, and to write any vector completely you need to know its magnitude as well as direction also, which means that you need to find its magnitude as well as unit vector in its direction. So unit vector in the direction of OA vector is nothing but e to the power iota pi by 4, because this OA vector is inclined at an angle 45 degrees. So any vector OA can be written as mod of OA vector into OA cap means unit vector. So this is, as I said, that OA vector, mod of OA vector is 3 and unit vector in this direction is e to the power iota pi by 4, right? Now to write AP vector, we must know its magnitude, which is given in this case is 4, and we must know a unit vector in the direction of AP vector. Now unit vector in the direction of AP vector can be obtained just by multiplying unit vector in the direction of OA vector by iota complex number. So unit vector in the direction of OA vector is e to the power iota pi by 4. Multiplying it with iota, we are getting unit vector in the direction of AP vector. So therefore AP vector is equal to modulus of AP vector and multiplied by AP cap, which is equal to 4 into iota e to the power iota pi by 4, which is equal to 4 iota into e to the power iota pi by 4. Now OP vector is actually the resultant vector of OA vector and AP vector, right? As you can see from the diagram, OP vector is resultant vector of OA vector and AP vector. OP vector is resultant of OA vector and AP vector. So simply write the vectors. OA vector is equal to 3 into e to the power iota pi by 4 plus AP vector is 4 iota into e to the power iota pi by 4. Taking e to the power iota pi by 4 common, we are getting 3 into 3 plus 4 iota into e to the power iota pi by 4, which means that option D is correct, right? As you can see that if you knew this concept already, then you could have solved this question within a minute. Since I had to explain the concepts, that's why I took this much time, or this was to illustrate, that's why. So for now in this video, I'm keeping the contents up to here only, and I hope that you have understood the concepts deeply and you shall be able to apply whenever it is required anywhere. And as you see, that okay, let's do something more also. We have time. Let's say there is another concept. Suppose that mod of z minus 3 is equal to 3, and then we have to show that this question is one of the brilliant questions that illustrates the concept of rotation, principle of rotation. So we have to show that z minus 6 divided by z is equal to iota into tan of argument of z, arg of z, where z minus 3 mod equal to 3. Now as I will show you in coming videos, that mod of z minus 3 equal to 3 is actually is representing a circle in complex plane. Z lies on a circumference of a circle whose center is at the point 3 comma 0 and radius is equal to 3. So how can you understand this? So you simply put z equal to x plus iota y and take the modulus. You will get a Cartesian equation of this circle. Very simple. Put z equal to x plus iota y. So x minus 3 plus iota y mod. So x minus 3 whole square plus y square equal to 9. So that's it. Let's say that this is the real axis and this is imaginary axis, and this imaginary axis is touching the circle at origin, and center of the circle is at 3 comma 0. Let's say this point where the circle is again cutting the real axis. Let's say there is any point P on the circumference of the circle. Let's say that point P is Z, and this angle of course is 90 degree, because angle in semicircle is always 90 degree. Let's say this angle is theta, which means that argument of complex number Z is theta. That's it. Let's say this point is A, so coordinate of this point is 6 comma 0 and coordinate of the center is 3 comma 0. Very good. Or in terms of complex number, you can simply write 6 and 3. Now applying the rotation concept about the point P, think that point P is Z, Z1 is 6 and Z2 is 0. So applying Z minus Z1 divided by Z minus Z2, that is Z minus 6 by Z minus 0, that is equal to mod of Z minus Z1, that is AP, and mod of Z minus Z2, that is OP. And e to the power iota pi by 2, because angle is in anti-clockwise direction, as you can see, 90 degrees in anti-clockwise direction, that is Z minus 6 by Z is equal to AP by OP can be written as tan theta, as you can see in right angle triangle. OPA, tan theta is equal to AP by OP. So, and e to the power iota pi by 2 in Cartesian form can be written as iota, so that is equal to iota tan, and theta, as I said, is argument of Z, so iota tan of argument of Z, and that is proved. Very simple, very simple. If you apply the rotation concept correctly, you will be very handy with solving the questions. And as I have shown, see, Euler form itself is a very powerful form for solving a tough question. Let us see one question that was asked in just previous year JEE Advance. This question that is being written on your screen has been asked in the 2020 JEE Advance 2020, and it is just you can say the modified version of that question. Not that much modified, but thing is that I have not written the options here. Question remains same. If mod of z square plus z plus 1 is equal to 1, we have to find the minimum value of mod of z plus 1 by 2. In that question, there were the options were given. Here I have not given the option. See, let's say that z square plus z plus 1 is a complex number, so its modulus is given. Let's say the argument of z square plus z plus 1 is equal to theta. So in Euler form, any complex number can be written as mod into a to the power iota times its argument. So mod of z square plus z plus 1 as given is 1, and I have assumed that argument is theta, so 1 into e to the power iota theta, that is equal to e to the power iota theta. So z square plus z plus 1 is equal to e to the power iota theta. Taking e to the power iota theta on LHS, we are getting z square plus z plus 1 minus e to the power iota theta is equal to 0, and I'm completing the square here, so z plus 1 by 2 whole square, that is equal to e to the power iota theta minus 3 by 4. Although you don't need to apply complete the perfect square, you can simply use the Siddharacharya formula of finding the roots of a quadratic equation, and that's it. So from here you are getting is okay, so let's say that modulus of z plus 1 by 2, in fact it should be modulus of z plus 1 by 2 whole square. So let me correct it, it's a typing mistake, and that should be equal to modulus of e to the power iota theta minus 3 by 4. Let's write e to the power iota theta in polar form. So this is mod of z plus 1 by 2 whole square is equal to cos theta minus 3 by 4 plus iota sin theta. And applying the formula of modulus, this is equal to a square root of cos theta minus 3 by 4 whole square plus sin square theta. Now expanding the whole square and then doing some calculations, few calculations, we are getting is sin square plus cos square is 1 plus 16 by 9, taking LCM 16 plus 9 by 16, minus, as you can see, 3 by 2 cos theta. So So this is basically 25 by 16. Oh, sorry, by mistake it has been written as 4, 25 by 4. Okay, please ignore it. So it should be 25 by 16 minus 3 by 2 cos theta. Okay, now see, we have to find the minimum of it. How can we find the minimum of it? So when we subtract the maximum from a constant value, we get the minimum, right? So if we subtract, when 3 by 2 cos theta is maximum, in that case overall will be minimum, and maximum value of cos theta is plus 1. We know it, right? In that case overall value will be minimum. So this mod of z plus 1 by 2 whole square shall be greater than equal to 3 by 25 by 16. Now I've corrected, minus 3 by 2 into 1, that is 1 by 16, that is equal to 1 by 4. Therefore minimum value of mod of 1 by z is equal to 1 by 2, and that's all. So this question was asked in JEE Advanced 2020, that is previous year, and as you can see that using this Euler form is very much helpful. So I hope that this video you have find very useful and you have enjoyed the video throughout. I've tried to give you the content that is most appropriate for JEE Advanced and JEE Main, and I've tried to deliver the concept as clearly as possible. But okay, of course we have to keep the video duration short, so that's why sometimes the speed of the video is a little faster. But if you find it, you can pause the video. Okay everyone, see you in the next video.